Somewhere out in the dark, there is an object so dense that a single teaspoon of it would weigh more than every human being on Earth combined. It spins hundreds of times every second. Its gravity could crush you into a smear of atoms before you ever touched its surface. It is not a black hole, it is the corpse of a dead star. And it is, without question, the most extreme object in the known universe. To make one, you have to kill a giant. When a star far more massive than our Sun runs out of fuel, its core collapses in less than a second. Gravity crushes it so violently that protons and electrons are rammed together into pure neutrons, packed as tightly as the nucleus of an atom. What is left behind is a neutron star. And the numbers are almost impossible to believe. Take the entire mass of our Sun, more than 1 million Earths, and crush it down into a ball just 12 miles wide, the size of a city. That is the density of an atomic nucleus, scaled up to the size of a mountain. One sugar cube of this material would weigh about 1 billion tons. That density creates gravity beyond imagination. On the surface of a neutron star, gravity is billions of times stronger than on Earth. If you dropped a single marshmallow from just a few feet up, it would hit the surface with the energy of an atomic bomb. Nothing solid could ever survive the fall. Not a spacecraft, not a planet, not you. Come too close, and the tides would end you. The pull on your feet would be billions of times stronger than the pull on your head. In an instant, you would be stretched into a thin stream of particles, a process astronomers grimly call spaghettification. You would be torn into atoms long before you ever reach the ground. But some neutron stars do something even stranger. They spin. As the dying core collapses, it speeds up, like a figure skater pulling in their arms until it is whirling hundreds of times every single second. From their poles, they fire beams of radiation that sweep across the cosmos like a lighthouse. We call these pulsars. When the first pulsar was found in 1967, its signal was so perfectly regular that astronomers half-jokingly labeled it LGM for Little Green Men. It was no alien beacon, but it was something almost as incredible. A natural clock so precise it rivals the atomic clocks we build on Earth, ticking away flawlessly for millions of years. And then there are the magnetars, the most magnetic objects in existence. Their magnetic fields are trillions of times stronger than the Earth's. If a magnetar drifted to within 1,000 kilometers of you, its field alone would distort the very atoms of your body, dissolving you, simply because your chemistry could no longer hold together. In 2004, a magnetar on the far side of our galaxy convulsed. In 1/10 of a second, it released more energy than our Sun gives off in 100,000 years. That flash of radiation crossed 50,000 light-years, struck the Earth, and physically compressed our planet's magnetic field from an object we could not even see with the naked eye. Sometimes, two neutron stars find each other and spiral inward and collide. The blast is called a kilonova, and in those final moments, the universe becomes an alchemist. The gold in your ring, the platinum, the rare metals of our world were not made by our Sun. They were forged in the collision of dead stars and scattered across space. A neutron star lives on a knife's edge. It is held up only by the desperate resistance of neutrons refusing to be crushed any further. add just a little too much mass. And even that fails. The star collapses again, past the point of no return, and vanishes behind an event horizon. A neutron star is the last stand of matter before it becomes a black hole. And what lies at the very heart of one, we still do not truly know. The pressure is so extreme that neutrons themselves may dissolve into a soup of exotic particles, a strange, frictionless liquid, unlike anything on Earth. Buried inside these dead stars may be a form of matter we have never seen and may never fully understand. The densest, the fastest, the most magnetic. Neutron stars are the ghosts of stars that died long ago, the strangest matter in all of physics, spinning silently in the dark. They are proof that when a star dies, sometimes it does not simply fade away. Sometimes, out there in the dark between stars, it becomes something monstrous,